Hello, my name is Julia Woodward. I'm a PhD candidate from the University of Florida, and today I'll be presenting our paper on It Would Be Cool to Get Stampeded by Dinosaurs, analyzing children's conceptual model of AR headsets through co-design. Augmented reality, or AR headsets, allow users to see and interact with virtual elements on top of the real world. Children are starting to use AR headsets in contexts such as education and gaming. However, little is known about how children use or think about AR headsets. As children are beginning to use these devices, it is important to understand their mental models and expectations because that can affect their perceptions of the headset and the usability. In order to see children's expectations, we developed a conceptual model of children's understanding of AR headsets using different participatory design or PD techniques. For this, we emphasized using AR headsets for tasks and defined tasks to the children as a job, chore, or project. We were interested in the types of tasks children would be interested in and how they want the devices to help them. We did this study in collaboration with Kids Team UW, which is an intergenerational co-design group from the University of Washington that includes 10 children ages 7 to 12. We ran 4 online 80-minute design sessions over Zoom, and during each design session, we would break into smaller groups to complete the activities. For the first day, we looked at designing an AR headset game using different craft materials and collaborating on Google Slides. We shipped the children craft materials that included face shields that the children could draw on and put on to simulate the screen of an AR headset. For the second day, we looked at designing elements in an AR headset that would be helpful while using Legos, using craft materials and Google Slides. We chose Legos as the activity because building with Legos has similar characteristics to working on tasks, such as being step-based and having an end goal, such as completing the build. For the third day, the prompt was to create a story of using an AR headset for doing a task. The groups collaborated together on Google Slides with the children directing the adults to find Google images to visualize their stories. They filled out 3 empty boxes to create their story that included the prompts, what is the task, what will you see, and how will it help? For the last day, the prompt was to finish a story of using an AR headset for one of the tasks from the previous day. They finished the story by filling in the boxes with the prompts, who would use it for the task, how would they use it, and what happens when they use it. After the design sessions, we transcribed the Zoom video recordings, which resulted in 372 child utterances. We then analyzed the data using affinity diagramming. Once we determined the themes from the affinity diagram, we grouped the themes into a conceptual model of children's understanding of AR headsets. Our conceptual model includes 7 main themes, which I will go through separately. For the first theme of user feeling, we see the themes distrust and independence. For distrust, the children were hesitant with trusting the AR headsets. For example, one boy said, "I wouldn't trust it because obviously AI can do weird stuff." For the theme of independence, we saw that the children only wanted to use the AR headset for tasks that were difficult for them or for when playing games. They did not want to use the AR headset when they thought something was easy or when they were trying to be creative. For example, one boy said, "If people get along easily without it, why do we need it?" Other themes that we saw include both user input and system output. For user input, the children considered a wide range of input modalities, including speech, natural interaction, body motion, and hardware. And for system output, the children considered 2D and 3D elements, voice, color, and the children even considered the location and amount of information being displayed. Another theme that we saw was system intelligence. The children expected a highly intelligent system that could recognize and transform their surroundings, provide suggestions, and manipulate time. For example, when designing using AR headsets in emergency, one girl said, "Put the people in green dots and then people who are in danger red dots." This highlights the expected intelligence as the girl expected the AR headset to recognize people, where the people were located, who was in danger, and then update her in real time. Another theme that we saw was user context. For user context, the children considered certain contexts such as using AR headsets for homework, video games, cooking, and in emergencies. And the children also considered the usability of using the headsets compared to traditional methods. We also saw a theme of system context. in which the children considered content topics and gameplay, and also designed having a social connection as well as the AR headset providing guidance. For instance, when designing using an AR headset for help with homework, one boy said, "And then I thought that you could have the AR saying, give you ideas and explain things to you." The last theme that we saw was system immersion. For system immersion, the children wanted an immersive experience that was first person, that included feelings and haptics, magnitude, outdoor usage, and that also where the virtual elements would interact with the real world. For example, one boy said, "I think it would be cool to get stampeded by dinosaurs." He wanted real life-size dinosaurs to be walking among him in his environment that he could touch and interact with. Based on our conceptual model, we provide design recommendations for designing AR headset experiences for children. For instance, we recommend to consider a trade-off between noticeability and usability for location of elements in the field of view. In the children's mental models, the children expected elements to be on the right-hand side of the field of view. However, people exhibit a leftward visual and spatial bias, which can lead to faster motion processing and greater detection accuracy. We also recommend to consider children's desires to accomplish tasks on their own and only provide support in AR headsets during difficulty. Based on our theme of independence, the children did not want help from the AR headsets when they were doing something that they thought was easy. Therefore, we recommend to only provide support in the AR headsets during difficulty. We also recommend to avoid interactive hand gesture commands in AR headsets for children. In our user input theme, we saw in the children's designs they considered interacting with the virtual elements through natural interaction and body motion. They did not consider interactive hand gesture commands. In the Microsoft HoloLens 1, the balloon gesture is used to bring up a start menu. However, based on the children's conceptual model, we recommend to avoid hand gesture commands. We also recommend to allow for extensive mobility and recognize whole body input for AR headsets for children. In conclusion, children expect highly intelligent systems that can recognize and transform surroundings and create immersive environments. Also, children want to use AR headsets for difficult tasks or games, not when being creative or accomplishing easy tasks. Overall, our study informs the design of content and experiences for AR headsets for children. Thank you very much.